So in today's video, I want to discuss a very important geometric property of any given object. It's called its area moment of inertia, or its second moment of area, depending on which textbook you're referring to. This is a very important property of a given object, and it's essentially the reason why you'll find so many of these I-beams in civil engineering products. It's very, very efficient use of the shape's area moment of inertia. We'll soon find out why. So in this example, it might help if you picture these two objects here, object 1, object 2, as just your common everyday ruler. Okay. Think about what would happen if I was to push the ruler, exert a force in the y direction, like that, and like that. Which object do you think would perform better in bending? By better, I mean, which would you think would deflect the least? I think you'll find that object 1 is probably the stiffest object, and object 2 would bend quite easily. Okay, so we're talking about bending on their x-axis, and that's key here. That's what we're going to discuss. Okay. The formula for area moment of inertia is Ix. Okay, so that's bending around the x-axis equals 1 over 12 times by the base times by the height cubed. Okay, and let's give these shapes some values. So this shape here, let's say this is 3 meters, and this is 1 meter. This is 1 meter, and this is 3 meters. So they both have the same area. This one here, shape 1 will be 3 meters squared, and shape 2 will also be 3 meters squared. Okay, but let's see what values we get from their moment of inertia, area moment of inertia. So for shape 1, let's calculate this. 1 over 12 times by its base, which is 1 meter, times by its height cubed, 3 meters cubed. Okay, so that will give us 2.25 meters to the power of 4. Okay, because this is meters 1 to the power of 1, and this is to the power of 3. So 2.25 meters to the power of 4. And let's do shape 2. Okay, Ix equals 1 over 12 times by its base, which is 3 meters, times its height, which is 1 meter cubed. That's going to give us 0.25 meters to the fourth. So note the difference here. Same shape, same area, except orientated differently. You'll see that this one here performs 9 times better than this shape here. And that's purely because of its area moment of inertia. That's all we've considered. Everything else is the same. And this is a reason why we have this I-beam. So this I-beam is, I guess, a composite object. It's got 3 different rectangles. 1, 2, 3. It's maximized its area moment of inertia. I think you'll find it's approximately 20 times better than even this shape here, orientated like this. And let's do some more examples. Please stay tuned for future videos.